So here is our kinematic equation. Our kinematic equation number 1 is distance is equal to the product of velocity and time. Our kinematic equation number 2, velocity is equal to the average of final velocity and initial velocity. Our acceleration due to gravity is equal to final velocity minus initial velocity all over time. And our fourth kinematic equation is 2 times acceleration due to gravity times distance is equal to final velocity raised to 2 minus initial velocity raised to 2. And our last kinematic equation, equation number 5, distance is equal to v naught times t plus 1/2 times acceleration due to gravity times time raised to 2. To solve for the total time to reach maximum height, we will use kinematic equation number 3, which is g is equal to final velocity minus initial velocity over time. But to solve for t up, we need to divide the equation by g and multiply it by t to get t up is equal to vertical component minus initial vertical component all over g, or the acceleration due to gravity. Substituting the given into our formula, T up is equal to 0 minus 50 feet per second all over negative 32 feet per square second. The value of our total time to reach max height is now equal to 1.5625 seconds. For number 9, solve for the vertical component of the velocity on top. So to solve for the vertical component of the velocity on top, we are going to use the equation Vy is equal to V naught sine theta minus acceleration due to gravity times time. Since we have already identified for the value of total time to reach maximum height, we are just going to substitute it together with the given and of course our physical constant, which is our acceleration due to gravity. Hence, Vy is equal to 100 feet per second sine 30 minus 32 feet per square second times 1.5625 second. Our vertical component of the velocity on top now is equal to 0. For number 10, solve for the velocity on v. So to solve for the velocity, we are just going to use the equation v is equal to square root of vx raised to 2 plus vy raised to 2. Since we have already identified the value of our vx and our vy, we are just going to substitute it into the equation. So v is equal to square root of 86.6 feet per second raised to 2 plus 0. So our velocity now is equal to 86.6 feet per second. For number 11, solve for the total time of flight. To solve for the total time of flight, we combine the time upward and the time downward of the projectile. The time upward equals the time downward. Since we have already identified the value of our T up, we are just going to copy its value to be our T down since the time upward equals the time downward. Hence, total time of flight is equal to T up plus T down. Substituting the value of our T up and T down, total time of flight is equal to 1.5625 seconds plus 1.5625 seconds. Total time of flight is equal to 3.125 seconds. For number 12, solve for the maximum height. To solve for the maximum height, we consider vertical motion and apply kinematic equations. So we are going to use kinematic equation number 4, which is 2 times acceleration due to gravity times distance is equal to final velocity raised to 2 minus initial velocity raised to 2. So to isolate distance, we are going to divide both sides by 2g. Hence, our equation now is distance is equal to final velocity raised to 2 minus initial velocity raised to 2 all over 2 times acceleration due to gravity. Since we have already have the given, we are just going to substitute it into our equation. Hence, distance or your maximum height is equal to 0 raised to 2 minus 50 feet per second raised to 2 all over 2 times negative 32 feet per square second. So the value of the maximum height now is equal to 39.06 feet. For number 13, solve for the range. To solve for the maximum horizontal distance or the range, we consider the horizontal motion and apply kinematic equation. Please see the image flash in your screens for your reference. So we have here the initial horizontal position, which is v naught x is equal to 86.6 feet per second. And of course, our initial time, which is 1.5625 seconds. And of course, our final horizontal position, which is v1x is equal to 86.6 feet per second. The total time along the horizontal is equal to the time from the initial position to the final position. Hence, total time along horizontal is equal to the time from the initial position plus the time from the final position. So total time along horizontal is equal to 1.5625 seconds plus 1.5625 seconds. So the value of our total time along horizontal is equal to 3.125 seconds. Since the motion is constant along the horizontal, the average velocity can be determined by equation number 2. Average velocity is equal to the average of final velocity and initial velocity. So average velocity is equal to final velocity plus initial velocity over 2. Since we already identified our given, we are just going to substitute it. So average velocity is equal to 86.6 plus 86.6 feet per second, which is our initial position. And of course, our final horizontal position over 2. So we can now use your calculator to solve for the value of average velocity. So the value of our average velocity is equal to 86.6 feet per second. The range can be determined by multiplying the average horizontal velocity and the total time of flight. Since we have already identified for the value of average horizontal velocity, which is 86.6 feet per second, and the value of total time of flight, which is 3.125 seconds, we can now solve for the value of the range with the kinematic equation number 1. So kinematic equation number 1 is distance is equal to v times t, or distance is equal to velocity times time. So the equation for range is equal to average horizontal velocity times total time of flight. Since we have already have the value of our average horizontal velocity and total time of flight, we are just going to substitute it into our equation. Hence, range is equal to 86.6 feet per second times 3.125 seconds. Our range now is equal to 270.63 feet.
The problem that you are going to answer in this activity is just like the examples we had just discussed a while ago, only that the angle is changed at 15 degrees. Solve the problem and show your clear solution.
Activity number 7. Solve the problem and show the clear solution. A projectile is thrown with an initial velocity of 100 feet per second at an angle of 15 degrees above the level ground. Calculate the first, horizontal component of the initial velocity. Second, vertical component of the initial velocity. Third, initial velocity. Fourth, horizontal component of the velocity after 0.6 seconds. Fifth, horizontal component of the velocity after 0.6 seconds. Sixth, Velocity after 0.6 seconds. 7. Horizontal component of the velocity at the maximum height or on top. 8. Vertical component of the velocity at the maximum height or on top. 9. Velocity at the maximum height. 10. Time to reach the maximum height. 11. Total time of flight. 12. Maximum height. And 13. The range.
Now, to reinforce what you have learned, let's have this activity. I want you to fill in the table with the correct computed values, then answer the question that followed.
What is the time of flight, maximum height, and range at angle 15, 30, 45, and 60? Then answer the following question. 1. Which has the longest time of flight? 2. Which has the greatest height? 3. Which has the farthest range? 4. In your PE class, particularly throwing events like discus, shot put, and javelin, can you apply what you have learned from this video? How?
Congratulations, students! You've made it to the end of the video. Thank you for joining me exploring, discovering, and enjoying life through Science Night. Again, I am your teacher Marvin. Thank you and God bless. Stay safe!